The U.S. Air Force has deployed its new EA-37B Compass Call electronic attack aircraft to support operations related to Iran, according to an announcement by United States Central Command. This deployment represents the first known operational use of the platform in a potential combat environment, marking a significant milestone in its transition from development to frontline service. Two EA-37B aircraft were recently observed at RAF Mildenhall, following their departure from Davis-Monthan Air Force Base on March 30th. The aircraft operated under the call signs AXIS41 and AXIS43 during the transit. The Air Force currently fields a small fleet of 5 EA-37Bs, with plans to expand to a total of 10 aircraft. The platform, which officially entered service in August 2024, is intended to replace the aging EC-130H Compass Call, bringing substantially enhanced electronic warfare capabilities. Notably, during a European demonstration tour in January 2026, the Air Force indicated that the EA-37B had not yet achieved full operational status. It remains unclear whether the aircraft has since reached initial or full operational capability at the time of this deployment. In this video, Defense Updates analyzes what can EA-37B Compass Call do for U.S. military in Iran. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. EA-37B Compass Call is based on a heavily modified Gulfstream G550 business. The G550 platform provides intercontinental range, 5,750 miles or 9,250 kilometers, and long endurance, enabling extended loiter times without refueling. For an electronic warfare aircraft, this persistence is central to mission effectiveness. It has a subsonic speed of Mach 0.8. The aircraft typically operates with a crew consisting of 2 pilots and multiple mission specialists, including electronic warfare officers and analysts. Advances in automation and human-machine interface design have significantly reduced operator workload compared to earlier platforms. Real-time data visualization, automated signal classification, and adaptive control systems allow the crew to manage complex electromagnetic environments more efficiently. While technical details of the specific systems on the plane are classified, few aspects regarding its capabilities are known. At its core, the EA-37B is engineered to operate within the electromagnetic spectrum as a non-kinetic weapons platform, specializing in counter C5 ISRT missions. Rather than destroying targets physically, it achieves strategic and tactical effects by denying, degrading, disrupting, or deceiving adversary systems. This includes high-powered precision jamming against communications networks, radar systems, and data links, as well as localized interference with navigation signals such as GPS. The result is the ability to paralyze enemy decision-making cycles without escalating to kinetic engagement, a capability of increasing relevance in contested and politically sensitive environments. A defining technical feature of the EA-37B is its SABRE, Small Adaptive Bank of Electronic Resources architecture, developed by BAE Systems. This system replaces legacy analog jamming with a fully digital, software-defined framework capable of dynamically adapting to the electromagnetic environment. SABRE enables real-time waveform generation, simultaneous multi-band operations, and precise targeting of specific emitters. Its modular design allows rapid upgrades, ensuring the platform can evolve alongside emerging threats. In effect, it transforms the aircraft into a reconfigurable electromagnetic weapon rather than a fixed-function jammer. Complementing SABRE is an ecosystem of software-defined radios, SDRs, and advanced RF receivers. These systems allow the EA-37B to scan wide spectral ranges, identify and classify signals, and transition seamlessly between passive monitoring and active jamming. This spectral agility is critical in modern electronic warfare, where adversaries employ frequency hopping, low probability of intercept signals, and complex emission patterns. Another technical advantage of EA-37B is its ability to conduct long-range standoff jamming. Operating at high altitude and extended range, the aircraft can remain outside the effective engagement envelopes of most surface-to-air missile systems while still projecting powerful electromagnetic effects deep into contested territory. This capability enables persistent overwatch and reduces platform vulnerability. From a technical standpoint, standoff jamming is enabled by a combination of high-output transmitters, directional antenna arrays, and advanced signal processing. These systems focus energy efficiently toward target emitters, maximizing effect while minimizing wasted power. The EA-37B can therefore support suppression of enemy air defenses, escort strike packages, and precondition the battle space before kinetic operations begin. Although primarily an electronic attack platform, the EA-37B incorporates robust signals intelligence, SIGINT, and electronic intelligence, ELINT, capabilities. Its sensor suite can detect, intercept, and analyze electromagnetic emissions across a broad spectrum, enabling real-time identification of hostile systems. Crucially, it can geolocate emitters with high precision, even when those emitters are mobile or intermittently active. This dual-role capability allows the aircraft to execute a find, fix, and finish cycle within the electromagnetic domain. By precisely locating targets before applying tailored jamming, the EA-37B avoids the inefficiencies of broad-spectrum interference and instead delivers focused, high-impact effects. This precision also reduces the risk of unintended disruption to friendly or civilian systems. The EA-37B is designed to operate as part of a broader, network-centric warfare ecosystem. Through systems such as Network-Centric Collaborative Targeting, NCCT, secure communication suites, and encrypted data links, the aircraft can share real-time information with other platforms across air, land, sea, cyber, and space domains. This connectivity enables cooperative electronic attack. For example, one platform may detect and classify a threat emitter. The EA-37B may then apply targeted jamming, and a third platform may exploit the degraded environment to conduct a strike or reconnaissance mission. Such integration significantly amplifies the effectiveness of each individual asset and reflects the increasing importance of multi-domain operations in modern conflict. The EA-37B Compass Call provides the United States with a powerful non-kinetic capability that would be highly consequential in any military scenario involving Iran. Its primary contribution lies in its ability to degrade, disrupt, and deny Iran's integrated military networks, particularly its air defense and command and control architecture. Viewers may note in this context that while U.S. military has extensively damaged Iranian military architecture, IRGC is still able to inflict damage. The destruction of a U.S. Air Force E-3 Sentry aircraft in Saudi Arabia's airbase is an example. The platform can target the architecture at multiple levels simultaneously. It can jam early warning radars to delay detection, degrade tracking radars to reduce missile accuracy, and interfere with data links that connect sensors to shooters. This effectively breaks the kill chain, meaning even advanced missile systems may struggle to engage targets reliably. At the same time, the aircraft can disrupt military communications, including radio and digital links used by Iranian forces and the Islamic Revolutionary Guard Corps, isolating units and slowing decision-making cycles. This creates operational confusion, reduces coordination, and increases the likelihood of errors under combat conditions. By degrading Iranian sensor fidelity and situational awareness, the EA-37B enables other aircraft, including non-stealthy platforms, to penetrate the airspace with reduced risk due to a less coherent defensive environment. Its ability to conduct standoff jamming from high altitude and long range, well outside many Iranian threat envelopes, means it can sustain these effects persistently without exposing itself to significant risk. There is no doubt that EA-37B Compass Call is set to play a crucial role in Operation Epic Fury,